Hello friends, welcome to my channel MathAlcoholic. So in this video I'll be starting the miscellaneous exercise of inverse trigonometric function. I hope the previous videos had helped you to some extent. So in this video, before starting these questions, let me tell that in the previous video of exercise 2.2 I had discussed very similar kinds of question in an elaborate manner in variety of methods. Okay, so I won't be going into once again into such details. I'll be just writing it formally as it is. Okay, we'll be solving the first 4 questions today. So starting from question number 1, we have cos inverse of cos 13 pi by 6. Alright, so to remind you once again, the cos inverse of anything always lies between 0 to pi, because that is the principal value that we had assumed. Okay, but 13 pi by 6 just exceeds 0 to pi, so we would have to bring it anyway into the range of 0 to pi so that we can just cancel this cos inverse by cos. Okay, so let us approach it. Clearly we can see 13 pi by 6 is nothing but 2 pi plus pi by 6. Alright, now let us introspect a bit more here. Cos of 2 pi plus 2 pi by 6. See, any trigonometric function repeats after 2 pi, and same is the case with cos here. Okay, cos starts from plus 1 and once again it repeats at 2 pi. Okay, minus 1 it goes, then once again at 2 pi it becomes plus 1. So 2 pi is just a cycle of repeat of every trigonometric functions. So there is no need to elaborate any more. So 2 pi plus pi by 6 we can easily write it as cos pi by 6, because same cyclic things are happening after 2 pi. Okay, so now we have replaced cos 13 pi by 6 by cos pi by 6, and now pi by 6 lies between 0 to pi. So we can open cos inverse of cos pi by 6 is equal to pi by 6. Alright, okay, now coming to question number 2 here. Similarly we will be solving tan inverse of tan 7 pi by 6. I am not explaining so much because I had explained in the previous video. You may see it for your own benefit if you want. So in the second case it is just almost the same. Since 7 pi by 6 does not lie between minus pi by 2 to pi by 2, which should be the principal range of this function, we have tan of 7 pi by 6 as tan of pi plus pi by 6 clearly. Okay, and if you remember, tan of pi plus x is equal to minus of tan x, so that is going to give you tan inverse of minus tan pi by 6. Now tan inverse of minus x, you know, that is equal to minus tan inverse of x. Alright, so this is going to be minus tan inverse of tan pi by 6, which is going to give you minus pi by 6, and you see minus pi by 6 lies between this range. Alright, now coming to the third question. See, we need to prove this expression. There are many methods to solve it once again, but I will be taking the simplest method of solving it. Okay, so coming to question number 3, we have to prove that 2 sine inverse 3 by 5 is equal to tan inverse something. So basically we have to find sine inverse in terms of tan inverse at first, then we can operate with 2 tan inverse x. We know the formula of 2 tan inverse x as tan inverse 2x by 1 minus x square. Okay, if you remember it, we are going to use that because that comes to be a much simpler expression, and the expression in the RHS is exactly what we want. Okay, so now we'll be assuming let sine inverse 3 by 5 equal to theta. So we will try to write this theta in the form of something else like tan. So from here we can see that sine theta is equal to 3 by 5. For sine theta is equal to 3 by 5, if you make a triangle, a right angle triangle, you will be getting the base with respect to theta as 4 by Pythagoras theorem. So tan theta, if sine theta is equal to 3 by 5, you easily get tan theta is equal to 3 by 4. Okay, so we can say the same theta is equal to tan inverse of 3 by 4. Alright, so we can write, so therefore 2 sine inverse of 3 by 5 is equal to 2 of tan inverse 3 by 4. Okay, now just by plain applying this formula, we have 2 tan inverse 3 by 4 means tan inverse of 2 into 3 by 4 by 1 minus 3 by 4 whole squared. Okay, this was the formula, I guess. So this is going to give you tan inverse of 6 by 4 by 1 minus 9 by 16. That is going to give you simply tan inverse of 6 by 4 into 7 by 16, and that in turn gives you tan inverse 24 by 7, which is RHS. Okay, hence proved. Okay, now coming to the last question of our topic today. Okay, so in question number 4, we need to prove that sine inverse of 8 by 17 plus sine inverse of 3 by 5 is equal to tan inverse of 77 by 36. Okay, so we will be approaching it in a similar way. It is very convenient to first convert sine inverse into tan inverse respectively, and then tan inverse x plus tan inverse y we will be applying. So let sine inverse 8 by 17 is equal to theta, and sine inverse 3 by 5 is equal to phi. Okay, because these two are different angles, so we can say sine theta is equal to 8 by 17 and sine phi is equal to 3 by 5. Alright, now since sine theta equal to 8 by 17, you can easily construct a right angle triangle with angle theta such that sine theta is equal to 8 by 17. You will be getting the base to be 15 by Pythagoras theorem. So you can say therefore tan theta is equal to 8 by 15, and from here similarly by constructing a 3 by 5 right triangle you will be getting the base as 4. So tan phi is going to give you 3 by 4. So simply you are going to replace theta by tan inverse 8 by 15, which is this, and phi, which is sine inverse 3 by 5 by tan inverse 3 by 4. Okay, so therefore sine inverse 8 by 17 plus sine inverse 3 by 5 is equal to tan inverse 8 by 15 plus tan inverse 3 by 4. Okay, solving it by the formula of tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy, which you know very well, I guess. So we will be getting this is equal to tan inverse of 8 by 15 plus 3 by 4 by 1 minus 8 by 15 into 3 by 4. Alright, solving it, this is equal to tan inverse of 8 4s are 32, 15 3s are 45. So 32 plus 45 gives you 77 by 60 into 1 minus 24 by 60. This simply gives you tan inverse 77 by 36, which is equal to RHS. Okay, and this is what was required, and hence we had proved. Hence proved. We have proved it. Okay, so I hope you have no problem understanding this. These are very easy basic class problems. If you just manipulate some formulas, you will get to the point. Okay, if you have any kind of problem, please feel free to use the comment section. I'll be trying to help you as much as I can. I'll be meeting you in the next video with the next set of questions. Thank you very much for watching this video.